In this lecture, let us understand various methods which are used for providing damping torque. The main function of damping torque is to damp or reduce the number of oscillations that the pointer or the deflecting system undergoes. Okay, as the number of oscillations are reduced, it comes to the steady or equilibrium state faster and the reading can be taken quickly. So to provide damping torque, these are the four methods that we are going to study in this lecture. Let us see the first method. See, first of all these canned photos that I have used in the video, these are taken from the book A Course in Electrical and Electronic Measurements and Instrumentation by A.K. Shawnee. So let us understand this first method. This is called as air friction damping. Now what happens here, this is the spindle and this is the pointer. So this is your moving or deflecting system. To your moving system there is a piston connector. The piston is made up of aluminium. Piston म्हणजे एक हँडलशा असता. Okay, you can see here एक हँडलशा असता piston म्हटलं. And the piston is inside this air chamber. The air chamber is filled with air. To the air chamber, one end is covered here and the other end is provided with a small opening so that the piston can enter into the air chamber. Okay. Now, as the pointer deflects or it moves, because the piston is also connected to the same chamber, along with the pointer, the piston also moves. So, suppose that the pointer is moving this side, then what will happen? The piston will move away from this end of the chamber. Or if suppose the pointer is moving this side, then what will happen? The piston will be going towards the end of this chamber. Okay. So if suppose the pointer is suppose deflecting, it is moving, and suppose this piston is going towards this end of the air chamber, then what will happen? As it is moving towards the end, the air present here inside the air chamber, it will get compressed, and as the air gets compressed, the pressure of air in this area will increase. So this increased air pressure in the air chamber will then oppose the movement of piston. Let's understand this properly. What I said, as the piston is moving towards this end of the air chamber, what happens? The air present here in the air chamber gets compressed, and because it gets compressed, the air pressure increases. As the air pressure increases, this increased air pressure opposes any further movement or motion of this piston, and the piston is made to stop there. As the piston is stopped there, the movement of pointer is also stopped. So that is how air friction works. This is air friction damping. Also, in the other case, if suppose the pointer is deflected in other direction, and suppose the piston is coming away from this end, okay, it is coming away from this end, it is going towards this end, then what will happen? The air present here in the air chamber will get compressed. There will be increased air pressure here which will oppose the movement of piston. So this is happening because of the air friction inside the air chamber, and because the piston's movement is stopped, opposed, the pointer's movement is also opposed, or in other words, the pointer is also brought to rest at its steady state or equilibrium position. So this is how air friction damping provides damping torque so as to make the pointer stop at the magnitude of the quantity to be measured. This is one way of providing air friction damping, and this figure B, this is another way of providing air friction damping. So what is happening here? There is the spindle to which there is a vane connected. This is a vane म्हटल्यार एक aluminiumची एक plate शी असता. Okay, to that vane there is the pointer connected, and this vane is placed in this air chamber. The air chamber, you can see here, this is in quadrant or sector shape. So as the pointer deflects or as the pointer moves, the vane also moves because both of them are connected to each other. And as the vane is moving, there will be air friction produced here because of the increased air pressure inside the air chamber, which will oppose the movement of this vane. Okay, so as the vane is brought to rest, automatically the pointer connected to the vane is also brought to rest faster. So this is how air friction damping works. Next method is called as fluid friction damping. So in that method, in place of air, there is some fluid used, and the fluid used is mainly oil. So here this is the fluid friction damping. What happens here? There is oil placed here, okay, and there is a disc in this oil. The disc is submerged in the oil, and this disc is having a rod here, a small rod here, and that rod is connected to the instrument spindle. Spindle will carry pointer then. Okay, so the pointer is connected to the spindle. Spindle is attached to this rod, and the rod is attached to the disc. So as the pointer deflects or as the pointer moves, the spindle will also rotate, and as the spindle rotates or as the spindle moves, this rod will move. As the rod moves, the disc will also start rotating. Okay, as the disc rotates, there will be a friction produced inside this oil, and because of that friction, the movement of disc will be stopped. The movement of disc will be opposed. As the movement of disc is opposed, automatically movement of the spindle is opposed, and automatically the pointer connected to the spindle is also brought to rest. Okay, the friction produced here inside the oil will be more than the friction produced in air. तुम्ही जर हात बेश्टो वाऱ्यार हालयलो जाल्यार बेगीन हालता. ओके, आणि जर तुम्ही तो उदकान भितर दवरून हाले जाल्यार you will experience a force due to water. So that is because the friction produced inside the water is more. The friction produced inside the fluid is more. Okay, so that is why the movement of your hand is opposed. Now here this is the second method. This is one method, and this is the second method. Here in place of disc, there are some vanes produced. There are some vanes placed here. Okay, so as the spindle rotates, these vanes will also rotate, and because there is friction produced here because of the oil, the vanes will be opposed from their movement, and they will be brought to rest faster. They will be brought to rest. As they are brought to rest, the spindle also is brought to rest, and as the spindle is brought to rest, the pointer is also brought to rest faster. So this is how fluid friction damping works. The next method is called as eddy current damping. Before understanding this method, let us first understand what exactly is eddy current. This is the magnetic field, okay? In this magnetic field, there is a moving conductor placed. This conductor is moving, okay? It is not at rest, it is moving. Now when this conductor is moving, the magnetic flux link with this conductor will change, and as the magnetic flux link with the conductor changes, there is an EMF induced in this conductor. Now if there is a closed loop path provided for this conductor, the induced EMF will produce an induced current here to flow through the loop, and this current can be measured here, and this current is called as eddy current. So eddy current म्हटल्यार कितें? एक जर कंडक्टर असा जो मॅग्नेटिक फिल्डान मूव जाता जाल्यार तितून एक EMF इंड्यूस जाता, आणि तो EMF कितें करता? करंट प्रोड्यूस करता, आणि त्या करंटाक म्हणटात एडी करंट. Now because this eddy current is produced here in the conductor, it will give rise to a magnetic field. We have seen that whenever current flows through a conductor, one of the effects is magnetic effect. त्या कंडक्टराच्या around magnetic field तयार जाता. So similarly, around this conductor also there is a magnetic field produced. आणि हे तुमचे पयलींचे magnetic field आसा जितून हो conductor move जाता. So हांगासर दोन magnetic fields जी तयार जाता, हे पयलींचे एक आणि हे एडी करंटान एक केला तें, दोन्ही magnetic fields interact जाता एकमेका वांगडा. The two magnetic fields interact with each other, okay, and they give rise to a force. The two magnetic fields are interacting with each other, and they are giving rise to a force which is called as electromagnetic torque. Now because of this electromagnetic torque, what it does is it opposes the movement of this conductor. वो conductor जो move जातालो तेका तो move जावपासून बंद करता, okay? And as the movement of the conductor is stopped, we say that damping torque is provided. So this is how eddy current damping torque is provided. Now next method which is there This is electromagnetic damping. This is like an application of the eddy currents. Okay, in this what happens, this is used mainly in the galvanometers. Galvanometer is an instrument which is used to detect the presence of current in the circuit. You would have used the galvanometer in the bridge circuit. Okay, so in this galvanometer, what is there is a coil which is moving in a magnetic field. So as it is moving in the magnetic field, there is EMF induced in the coil. This EMF gives rise to a current which is called as eddy current. Because of eddy current, there will be magnetic field. The magnetic field will interact with the existing magnetic field, and there will be an electromagnetic torque produced. And this electromagnetic torque will oppose the movement of the coil. So this is how electromagnetic damping is provided in the instrument to provide damping torque. So these are all the 4 methods which are used to provide damping torque. So with this, we have come to an end of our unit 1. Thank you.